Hello everyone, my name is Golnaz. Today I'm presenting my recent work, which is in collaboration with my advisor, Dr. Sumner at Simon Fraser University. Smaller test cases are more easily reproducible and make debugging easier. However, test cases that exhibit bugs are frequently large. That's why test case reduction is of great importance. Given a software under test, a test case is fed into the software as an input, which may reveal a bug. This test case could be large and contain many parts that are not relevant to the bug. So the large test case is fed into a reducer, which will try different smaller test cases and interacts with an oracle to check whether the smaller test case exhibits the bug or not. When a smaller test case is found, the process can be repeated to find further reductions. For example, source code of a program can be a test case for a compiler like GCC. These inputs can have complex structure represented by abstract syntax trees and a grammar. There are handcrafted reducers like creduce that provide powerful reduction abilities, but they also require significant expertise and investment to produce. On the other hand, there are more general-purpose reducers like persys and pardis that are easier to build but are less powerful due to the lack of domain-specific knowledge. For example, these reducers may try removing the definition of a function while its use is still present within the test case, which will lead to an oracle check on a test case that is not a valid program. We propose to train models using the abstract syntax trees of available test cases to recognize these invalid variants and skip the oracle check on them. Details can be found in our paper. We evaluate our models on 14 large C test cases generated by CSmith, a tool for randomly generating C programs. These test cases trigger bugs in GCC and Clang compilers. We compare our best model, that is the node type model, with pardis, a general reducer, and creduce, a customized tool. Looking closely at the reduction time, we see that the model-guided approach is faster than other approaches. When looking at the resulting size, it is comparable to the other general technique, but handcrafted techniques like creduce are still the best. To find the middle ground in performance and reduction power, we use our model as a pre-processing step for creduce and pardis. We are able to still perform faster while interestingly improving the reduction power and obtaining test cases that are very similar in size to the ones generated by the two techniques. To summarize, test case reduction is important because smaller test cases make debugging easier. The existing reducers are either customized that are hard to develop or are too general that will generate many invalid test cases. We can avoid performing oracle checks on these invalid tests by learning a model that recognizes these variants before performing the expensive oracle check. This work is a first step in learning models to make reducers more accessible. I would like to invite you to visit our tool at the following link. Thank you, and I'm looking forward to the discussion.